Welcome to the session on trig identities and equations. In this unit, we will be looking at key concepts through review exercises. The objectives for this session are to review previous topics through exercises, namely, using trigonometry to find missing sides or angles, sketching trigonometric graphs and solving related problems, solving linear equations, and solving quadratic equations. Pause the video and have a go at these review exercises. When you are ready to view the next set of exercises, press play. Pause the video and have a go at these review exercises. When you are ready to view the solutions, press play. First, let's review trigonometric ratios. In a right-angled triangle, the three trigonometric functions are sin theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. So let's have a go at review exercise 1a. Find the length of x in the given diagram to one decimal place. So as indicated, x is the opposite to the angle. 3.5 centimeters length is the adjacent to the angle. And therefore, when we solve, we're going to use tan theta equals opposite over adjacent. So substituting in the values gives us that tan 25 degrees equals x, which is the opposite, over 3.5 centimeters, which is the adjacent. And therefore, rearranging the equation gives us that x equals 3.5 times tan 25 degrees. And therefore, x is equal to 1.6. Now let's have a go at review exercise 1b. We are required to find the length of x in the given diagram to one decimal place. For the angle given, we have the opposite, which is equal to 4 centimeters, and we have the hypotenuse, x, which we are required to find. The angle we are considering is, of course, 55 degrees. So therefore, we're going to use the formula sin theta equals opposite over hypotenuse. Substituting in the values gives us that sin 55 degrees equals 4, which is the opposite, over x, which is the hypotenuse. And then rearranging gives us that x is equal to 4 over sin 55 degrees, as shown. And therefore x equals 4.9. And now for review exercise 2a. Find the size of theta to one decimal place in the given diagram. So in this situation, we have the opposite, which is 1.5 centimeters, and the hypotenuse, which is 7 centimeters. So when we solve, we need to use the formula sin theta equals opposite over hypotenuse. And substituting in the values, we have sin theta remaining as sin theta equals opposite, which is 1.5, over 7, which is the hypotenuse. And therefore, when we inverse sine, we obtain theta equals sine inverse of 1.5 over 7, which implies that theta is equal to 12.4 degrees. And now for review exercise 2b. Find the size of theta in the given diagram to 1 decimal place. So we have the opposite, which is 2 centimeters, and we have the adjacent to the angle, which is 3.5 centimeters. So we're going to use the formula tan theta equals opposite over adjacent. And substituting in the values gives us tan theta remaining as it is, equals opposite, which is 2, over the adjacent, which is 3.5. And therefore theta equals tan inverse of 2 divided by 3.5, which implies that theta equals 29.7 degrees. Before moving on to the next exercise, let's take a quick look at trigonometric functions. The graphs of sine, cosine and tangent are periodic. This means that they repeat themselves after a certain interval. Let's now consider review exercise 3a. We are required to sketch the graph of y equals sine x for x between 0 and 540 degrees. This will look something like the graph you can see on your screen. In part B, we are required to find how many solutions there are to the equation sine x equals 0.7 in the range x between 0 and 540 degrees. So let's find 0.7 on the y-axis. This appears somewhere here. Now, at this point, there is one solution, as indicated. However, if we extend this line, we can see that there are actually 4 solutions in this range. The solutions are 44.4 degrees, 180 minus 44.4 degrees, 360 plus 44.4 degrees, and 540 minus 44.4 degrees. So this gives us the solutions as shown on your screen. And now for review exercise 4a. We are required to solve 8x plus 2 equals 2x minus 1. So in order to solve this, we need to isolate all the x's on one side and all the constants on the other. So let's subtract 2x from both sides. As shown, to give us that 6x plus 2 equals minus 1. As you can see, there are no more x's on the right-hand side. Now we need to make sure that the constants are all on the right-hand side, as the x's have now all been brought over to the left-hand side. So let's subtract 2. As shown. And this time the constants on the left-hand side have been removed. So we're left with 6x equals minus 3. And finally, dividing through by 6 gives us that x equals minus a half. And now for review exercise 4b. We are required to solve 3 times x minus 1 equals 4 times x minus 2. We need to first expand these brackets and then rearrange. So expanding gives us 3 times x minus 3 times 1 equals 4 times x minus 8. So as before, we're going to try and ensure that all the x's are on one side and all the constants are on the other. So we subtract 3x from both sides, as shown. And then tidying up gives us minus 3 is equal to x minus 8. And now finally we're going to try and ensure that all the constants are on the other side. So we add 8 to both sides, and of course this is done in order to remove the constants on the left-hand side, which gives us x equals 5. And now, before we go on to our next exercise, let's quickly review quadratics. Quadratic equations are written in the form y equals ax squared plus bx plus c, with a, b and c real and a not equal to 0. Quadratic equations can have 1, 2 or no real solutions. Solutions to an equation are also called the roots of the equation. So let's take a look at the steps for solving a quadratic by factorisation. First, write the equation in the form ax squared plus bx plus c equals 0. Then factorise the left-hand side. And finally, let each factor equal 0 and solve. So let's take a look at review exercise 5a and apply these steps to this exercise. So we're going to solve x squared minus 6x minus 7 equals 0. And then find two factors of AC equals 1 times minus 7 equals minus 7, which add up to b equals minus 6. Now the factors are 1 and minus 7, since 1 times minus 7 equals minus 7, and 1 plus minus 7 equals minus 6. And therefore, we can rewrite x squared minus 6x minus 7 as x squared minus 7x plus 1x minus 7. And this equals x times x minus 7 plus 1 times x minus 7. And so we can factorize as shown. So we have x plus 1 times x minus 7. This implies that x equals 7 or x equals minus 1 when x squared minus 6x minus 7 equals 0. And now for review exercise 5b. Solve 5x squared plus 2x minus 3 equals 0. As this equation is already in the form ax squared plus bx plus c equals 0, we can directly move on to step 2, as we did in the previous exercise. We need to find two factors of AC equals 5 times minus 3 equals minus 15, which add up to b equals 2, as shown. The factors are 5 and minus 3, because 5 times minus 3 equals minus 15, and 5 plus minus 3 equals 2. And therefore, we can rewrite 5x squared plus 2x minus 3 as 5x squared plus 5x minus 3x minus 3. And then we can factorize the pairs. So we have 5x times x plus 1 minus 3 times x plus 1. So as you can see, x plus 1 is common. And so we have x plus 1 here and 5x minus 3 here. And the expression has been factorized. Therefore, the solutions are x equals 3 over 5 or x equals minus 1 when 5x squared plus 2x minus 3 equals 0. And now for review exercise 5c. We're going to solve x squared plus 5x plus 17 equals 3x plus 20. We need to write the equation as ax squared plus bx plus c equals 0. So let's rearrange this equation. We're going to subtract 3x from both sides in order to get everything step by step onto the left-hand side and 0 on the other. So we have x squared plus 2x plus 17 on the left-hand side, and the 3x's on the right-hand side cancel out, leaving us with 20 on the right-hand side. And now we subtract 20 from both sides, as shown, to give us x squared plus 2x minus 3 equals 0 overall. So now we need to factorize x squared plus 2x minus 3 equals 0. And again, we need to find two factors of AC, which equals 1 times minus 3 equals minus 3, which add up to b equals 2. The factors are 3 and minus 1. Since 3 times minus 1 equals minus 3, and 3 plus minus 1 equals 2. And therefore we can rewrite x squared plus 2x minus 3 as x squared plus 3x minus x minus 3, as shown. And this equals x times x plus 3 minus 1 times x plus 3. And of course, as you can see, x plus 3 is common. So we can position that here and x minus 1 here. And the expression has been factorized. This implies that x equals 1 or x equals minus 3. So this brings us to the end of this session. If you have understood its contents, you should be able to use trigonometry to find missing sides or angles, sketch trigonometric graphs and solve related problems, solve linear equations, and solve quadratic equations. Thank you very much for listening.